That's me, in 1975, an electronics and computer engineer by education who later in life turned software engineer by trade. What I'm showing you here is my traffic simulator. My concern is the future of rail and road traffic. In this display, each vehicle represents an autonomous car. For cars to cooperate with their environment, each one is controlled by a particular piece of software that can exchange data with each other vehicle and also the nearby surroundings. Resulting from this is a unique behavior of each individual vehicle. The roads the cars run on are made up of road segments. On entering, a car is registered online at such a road segment. In turn, the road segment provides local information like traffic lights, speed limits, and other nearby items. Similarly, the tracks the trains run on are made of track segments, which, for safety reasons, have to be booked in advance. Once a track segment is booked, no other train is allowed to ride on that segment. Driverless trains and autonomous tracks need a new set of digital traffic regulations. Designing these rules is by no means an easy task. These rules have to square two opposing objectives. On the one hand, they have to provide safety, and on the other hand, they must not have any adverse effect on traffic performance. The Lifemap simulator is a valuable tool for designing and testing new traffic regulations. If used properly, autonomous traffic will be safer and at the same time more efficient than conventional traffic. Before entirely going to autonomous, the digital safety will have to be improved in use. Therefore, years ahead of switching to fully driverless, any vehicle, old or new, railroad and automotive, will by law have to be fitted with digital safety devices. The railroad safety system currently being tested here is displayed on the right. Two driverless trains, a blue one and a red one, are running towards conflict on their autonomous tracks. A few segments ahead, they are joining into one single track. The red signal at the tip of the booked stretch indicates that the train is trying to book the next segment and is not yet done. If booking fails, all virtual signals turn red and the train has to stop. A stopped train then cannot continue its journey until the blocked and therefore not bookable segment is set free again and subsequent booking was successful. For both trains, the distance covered by booking is shown by a line drawn in their respective color. Green or yellow virtual signal lights are shown on the secured stretches to indicate that it is safe for the train to drive on. By the way, the length ahead of the booked stretch is determined by the speed of the train. In the middle, you can see the segments and points in case. Do have a look now at rail and road safety. Two mini windows are seen at the top, giving a preview on car communication and automotive safety, whereas a train safety summary and repeat expands at the bottom. Driverless trains are pushing their safety range forward by booking segment after segment at a forward distance corresponding to their speed. The stationary train cannot go ahead as long as the single track to enter is booked by an upcoming train in opposite direction. Because of being in standstill, or respectively because of not being able to book forward, no ahead safety range is seen. Mind you, safety communication facilitated through a robotic map gets the driverless train information needed for self-control. By this means, the stationary train is waiting for a successful booking ahead. Once the safety range is confirmed, the train can continue its journey. Looming on the horizon are robotic taxis, for short, robo-taxis. Their presence in cities, big and small, will make redundant not only taxi drivers, but also privately owned vehicles. Although this means losing a substantial part of their business, the automotive industry is fiercely competing to be the first on the market. However, only the first 2 or 3 automotive companies will stand a chance to survive, and they may be pipped to the post by one of the big digital players that are coming in, like Google and Uber. The hardest part, anyway, in the near automotive future, will be the transition from driver to driverless traffic. In that period, new rules will have to be introduced and put to the reality test. Mind you, both rules, new and old, will be in effect at the same time for a while, and both technologies, old and new, will be used in parallel for years to come. Therefore, they will have to be compatible with each other. At this point, a RoboMap comes in handy, not only to design rules, but also to test their effect on traffic flow. For this reason, Lifemap lets you watch the inside proceedings of the RoboMap as well as the internal processing of vehicles. Therefore, various display modes are provided. As shown here, vehicles appear as circles with the outer ring revealing their internal control states. Red is for braking, brown for standstill, and so on. In the perpendicular bar, the green part is related to speed. If at standstill, the bar turns completely black. And finally, there are 3 numbers. The middle one is the vehicle's unique identity number, whereas the top and the bottom ones are the numbers of vehicles ahead and behind. They indicate that a digital communication between them is established. In a driverless world, robotic intersections will be needed, which automatically enter communication with approaching vehicles. For negotiating conflicting traffic, various means have been tested. Among those, sentry points have been established best. Sentry points will be showing on the RoboMap as they are put to the test. They do not exist in reality, they just virtually exist as code and data on the traffic control computer. Set up with going regulations, sentry points assist in preventing accidents and deadlocks in crossings. And by helping in dynamically rearranging incoming traffic, they make for improved traffic flow. For that purpose, they are registered on nearby road segments. Vehicles entering such a segment automatically connect to all sentry points listed there. Communication is displayed by a colored line inherited from the connected vehicle. Car to sentry point has only one color, whereas car to car has 2 colors, reflecting those of the 2 vehicles that are exchanging data. Sentry points also show colors derived from vehicles. The outer ring's color points to the vehicle that is given right-of way, and the center shows the color of the vehicle booked next. The safety system tested here may even prove reality-worthy and come into general use. Setting up the autonomous future according to these ideas will turn out cheap and at the same time safe. Measures shown here are coming almost for free. Although having a profound impact on the real world, no extra hardware will be needed. It is all in the mind. The signals, the sentry points, and the connection to and from segments. It entirely consists of software that only needs a computer to run on. and the means of connecting to the real world are already in place. Mobile communication and geopositioning are nearly everywhere available, like GPS and 5G. Once honed in test cycles, the transition to future traffic can proceed in an orderly fashion. What looks confusing and expensive when displayed on screen actually is a well-organized, coherent system and makes traffic much smoother than ever before. Admittedly, on the other hand, recognizing and coping with the unforeseen is not covered by this simulator. Radar, LiDAR, cameras and AI need still be fitted to understand what's going on in front of a vehicle. On the path to autonomous traffic, this can present a further stumbling block, which might be cumbersome and expensive to negotiate. Anyway, there is one positive. No matter which way we are switching into the driverless world, new jobs will be coming up. Remote drivers will be needed to cope with unforeseen situations on the ground. They will work very much like ground pilots in today's air traffic. They can take over by remote control and remote vision when artificial intelligence fails. Thank you for watching. However, this wasn't all that Lifemap and Mapsim can do. There is, for instance, 3D volocopter control and airport traffic management. And for C++ programmers, I have something special installed.